So the last time we were all together, we were working on just figuring out how to find the axis of symmetry. Who could remind me what the axis of symmetry is? Nope. All right. Opposite, you're going to use opposite B over 2A. What is what is a B? What's an A? Where are we finding that? All right, you're going to have it in standard form, which is y equals ax squared plus bx plus c. And opposite b means if b happens to be positive, you make it negative. If it's negative, you make it positive. So you do opposite b over 2a, the 2's every time, and then solve that or simplify it, and that's your x value, which is your axis of symmetry. What does that line do? What is its purpose? What does it do to the parabola?
Curves.
Sets a starting point.
No, well, that's the vertex. But what does the axis of symmetry do? It's cutting the parabola in half, making it be a mirrored image. All right, that's the x. It's axis of symmetry, but it's also the x value for your vertex. Then, how do we get the y value of the vertex? You plug it in the standard form. In standard form. And that gives you the y value. Then then you plot that. That vertex being your highest or lowest point in our drawing of the parabola. And I think it was JoJo who explained why we graph it first, what its purpose is. And it takes us to the highest point, and we know we don't go any higher. That's where we start either drawing it down or drawing it up. All right, that's why we put, though, on the table, your vertex on the middle, in the middle of the chart, because you're going to have points below it and above it. And then like in problem 2, the vertex was -2, -4. And we put that in, and then we picked the points just up to the right of it and just to the left of it on the x-axis, creating the values we're going to use for x, and then we take it and plug it back in. All right. But hold on. We're going to look at 2 and 3 in a different format. So let me go to the next page that we've already done. Hold on, open. That was why we had 1 and -4, and we did 2, 3, 0, -1, and worked it accordingly. Plugging in our x value to get your y. And then graphing. All right, how do we know at a glance if we're going to have a parabola that opens up or opens down? Yes, so if the first number, our lead coefficient, that A, is positive, it's like a happy face, we have it going up. If it's a frowny face, in other words, a negative number, then our parabola is going to open down and go from there. All right, we talked about ignoring, what did we ignore in the last class? Vertex form. Now we're ready to tackle it. First, what's the vertex? What do we mean by vertex? Highest or lowest point. And we have to go through a whole lot of work when we're in standard form to find the vertex. You got to do opposite b over 2a, then go plug it back in and get the y. So, vertex form is really cool. It is holding the vertex in its possession. So just looking at it, you will be able to figure it out. But there's a certain way you look at it. So, number 2, the equation is in vertex form. Now, I need to repeat this like 17 times. You cannot look at standard form and come up with the vertex, okay? You still have to do opposite b over 2a. I'm already having people grabbing numbers from standard and making it. That's the long form. And you can put standard in vertex form, but not without finding the vertex first, okay? So do not grab the numbers from standard and just use them as your vertex. So let's talk about what we got. Ordered pair. A vertex is an ordered pair, right? We agree. So I want to just make a quick mention about ordered pairs. We could have X, Y. Ordered pairs, they're in alphabetical order. X and then Y. We also have talked about something. What would those two letters represent? Yeah, bye. What would domain and range? Domain goes with the X. Range goes with the Y. And they're in alphabetical order. Okay? Now, vertex. It's going to contain an X and a Y, the vertex form. And so we can't have two X's and two Y's, because then it gets complicated. So I don't know why they didn't just stay with DNR, but somebody probably like their mama's name or something. I don't know where they came up with the letters, but they do H, K. Again, alphabetically, H is going to be your what value? Your what? X. And the K is going to be your Y. All right. Let's look at what we are going to be working with. So I'm going to erase just a drop on here. Let's see over here. The vertex form, and here's your template. You will have Y equals A. What is an A? What does that mean? It's that lead coefficient that decides if it's a happy face or a frowny face. If it's a negative number, you put the negative sign with it. Then X, this is opposite H.
Why can't you just say like X or Y?
Because then it's too many X's and too many Y's. X, I know. X opposite H. It says minus H, but remember when we did opposite B over 2A, we wrote it as minus B? So it's that same thing. Opposite B over 2H squared. If we don't square it, you're going to have a linear. You got to have it squared to make a parabola. Okay? And then plus K. Alrighty? Opposite B. A parentheses X opposite H squared plus K. In other words, the K sign is not going to change. So, what is the vertex for number 2?
-2, -4.
Perfect. Look how easy that was. -2, because it's opposite. In our equation, it's a positive 2. So, opposite that, -2. The K is that last number hanging out by its lonesome, and you keep its sign. If it's negative, it is negative. If it's positive, it stays positive. So -4.
So how do you do that?
We go back to it has to be in vertex form. It's +2. That's your opposite H. So what is opposite of +2? -2. There's your X value, -2. -2. And then it's -4. That is your K, which is your Y.
So is it always going to be those two numbers? Or not those two exact, but those two spots?
Those two spots.
Okay.
Always, because it's opposite H plus K.
Gotcha.
So see how easy that is? But I have people grabbing the B and the C in standard form. Not the same thing.
I have a question.
Jojo.
On the like, what is it called? What is this? No one. Whatever that is. Does it matter?
Whatever that is.
Does it matter if you go like
Vertex.
negative that way?
As long as if you put a -3 there, you need the -4 to be there. If you put -1 there, then 0 needs to be there. You build it either way. No, as long as you put going either up or down. All right, we're not going to be using that table for long though, Jojo. I got special steps for that too. All right, so what's the axis of symmetry then? It's that same process. That the x value is still your axis of symmetry, your AOS. We just kind of go backwards into it. So this is x equal. All right, and then the rest, yes, sir.
And then you only did this like thing if it's like parentheses in the front.
If it's in that format, yes. Now if we're in that format and you're told to put it in standard form, what do? How would you put this in standard form? You work it. You use PEMDAS. Do we have any parentheses?
Yes.
Yes, but can we do anything inside the parentheses? It's x plus 2. I mean, if we knew x, yes, but we don't. So what's the next thing we do? Exponent. But we're squaring a binomial. What does that mean we're going to do to it?
Foil it.
Yes! Look at you. We're going to foil it. So, x plus 2. X plus 2. It's not x squared plus 4. Okay? We'll have x squared plus 4x plus 4. Then what do?
Factor it.
Olivia?
Why would it be 2x in the middle?
Because it's outer, inner. Outer is 2x, inner is 2x.
You already added them.
I just went ahead, yeah. Yeah, I'm kind of through doing that shuffle step with y'all. Y'all factored since before Christmas. We're just throwing it in there. What do you do next? Look back at the equation. We have solved we've worked parentheses, we've worked exponents. What do we do next? What's left? We've worked this. What do we need to do next?
Multiply.
Multiply what?
I'm not sure. That's just the next letter.
It is the next letter. Look at 2, our equation. Where is there multiplication?
And the parentheses. Outside the parentheses. Distribution.
Distribution. Take that -2 and distribute. All right? -2, distribute. And you would get -2x squared minus erase minus 8x minus 8. What's the next thing we do? Look back at the equation. What have we left alone?
-4.
What do you do with the -4?
Put it at the end.
And now what do we do?
Subtract those.
Yes, which gives us what?
Minus 12.
-12. So in standard form, this is -2x squared minus 8x minus 12. So do you see the vertex is -2, -4. It is not 8 and -12. All right, you see the difference. You cannot look at standard form and just glean that -2 and -4 is the vertex. You have to do opposite b over 2a and then plug it back in. All right, so I'm just trying to make sure y'all don't try to do that. Then you're going to take all of your letters, the numbers, put them into the table. Oh, y'all, that gets to be a lot of work, doesn't it? So y'all ready to see the shortcut?
Yes.
Okay. Who can count by odd numbers? You can count by odd numbers? If we're starting at 1, what's next?
3.
What's next? That's as far as I need you to go. 1, 3, 5. We're going to use the 1, 3, 5 method. Okay? But let me say this. We've got to show it to you 2 different ways. 1, 3, 5 method. Because that's when the lead coefficient is 1. I'll show you what to do when the lead coefficient is larger. But if the lead coefficient is 1, we're going to use 1, 3, 5. You still have to find the axis of symmetry vertex. okay? Or if you're in Vertex form, you still got to figure out where it is because that is still the starting point, okay? So you can't change that. So, hold on. Oh, nope. We're going to go to the back. Well, I keep drawing it. Hold on, guys, sorry. Number 4. We worked this yesterday. What did we get as the vertex?
1 -4.
We ended up with 1 -4. I'm not going to work through that because we did that yesterday. We're going to go to 1 -4. And we're plotting. Are we going to have a happy face or a frowny face? This is why it's important that you know which way to go. When you have a table created, it plots it as a happy face or a frowny face. If you do the shortcut method, you have to know which way you're going or you'll plot it wrong. So, yes, we're going to go happy. When you were creating the table, you went over one and plotted, and then you went over to the next one and plotted, right? So, and then the mirror, the other side, was the same plottings, just with a different X. So we're going to start at the vertex. We have to go over one because we're plotting on the next one. And you go up one. Over one, up one. So you already have a drawing there, right, on your piece of paper?
Yes.
So go over one from our second dot and count up how many places you go up. 3. Over one, up 3. If we had a big old chart, we would go over one, up 5. So it's 1, 3, 5. Start at the vertex, go over one, up 1. And then over one, up 3. So then we go back to the vertex and we go over 1, up 1. Over 1, up 3. So a lot easier than doing the chart. It would never hurt to fill in the chart and maybe do your X's and just check one to be sure. Because you want to be sure that you're going in the right direction of the graph. Jojo.
Can you explain where you got like over 3, like up 3, or like
Yes, there is just, right, we graphed it like this yesterday using the table. And I think with our table, we had a vertex of 1, -4. And then with plugging everything in, we did a 0, -3. And we had a -1, 0. And then we did 2 and 3, and we had a -3 and a 0. All right, we did the work for that. But there's a method, and it is called the 1, 3, 5 method. 1, 3, 5. This is when the lead coefficient is 1. But you have to graph your vertex first. So you got to figure that out. You can't just, you'll do that. There's no way to find it other than working it. Then you just go over 1, up 1. There's your 1. Over 1 more, up 3. Not from the original, but from where your next plotted point. And then if we were going further, we would go over 1 and up 5. And then it's the same plotting. You just really go to the next line and find your mirror. Olivia.
So, like, you did that number 6.
Not yet, but almost. Why can't we?
Because it doesn't have.
What's the lead coefficient? 2. Okay, we're just about to touch it. Gabe.
What does this do with vertex form, or does it just help fill out the table?
It helps with not having to do the table thing.
So what do you put on vertex form?
You still have to go opposite B over 2A.
Like, what do you put like just blank?
For number 4?
Yeah.
Well, y'all should have had it filled out from yesterday. That's why I grabbed it. We did opposite B over 2A, and you came out with the AOS as x equals 1. And then we plotted, took the 1 and put it back in, and we got 1, negative 4.
Oh, the vertex form.
The form. The vertex.
Oh, Vertex, you tell me. How would we, let's see, can you figure out how to write, I thought you were, I'm sorry, form, you did say that. How do you think you put Vertex, this information into Vertex form?
The H.
Just run a smiley face.
Helen Keller.
So, it needs to be y equals a x opposite h squared plus k. Okay, there's our format. What is our a? What's the lead coefficient? 1. You can either put a 1 or just not put anything because that would be an understood 1. But I like putting the 1 so we don't leave anything out. We know it is, and then you're going to have, that x is written there. Opposite h means what?
Positive.
Negative 1. Opposite.
So the H is just A. I like the X.
The x value. Yes, it's the x value, but you go opposite. Squared. Don't leave off that square or it's not even a quadratic equation. How do I end it?
Minus 4.
-4.
So that's that.
That's Vertex form.
So the K
And
and
that's
the Y are the
Now
same
that you
thing.
put in the blank.
That's what we did over here when we wrote this.
Okay, I wrote that.
And that's
X, Y, D, R, H, K, alphabetically.
That's all just the same.
Yep. Able, and then it's opposite H, so when you find the vertex, your
You're already there.
X value for the vertex has to be opposite going into the equation. But the K, because it's plus K, you take with it. It's not positive every time, but it doesn't change the value. So if it's a -3 as your Y, you would leave it -3. That doesn't change.
And so is that what we would put in the blank?
That's what you would write in vertex form blank. Would be y equals 1 x opposite h, so -1 squared, and then it is a -4, and that value stays. Okay? Well, if you solve it, you're going to be back in standard form. And, so yes. Now, any questions on vertex form? You know how to find it. You know how to now take the vertex and create one. Let's look, though, at number... for 5, you would, when you get ready to graph, if you want to use the 1, 3, 5 method, what is our lead coefficient?
Negative.
It's a negative, but it's a -1. So you still use 1, 3, 5, but you're just going to count over 1, down 1, over 1, down 3. That's why it's important that you know, because you're not doing the table, your XY table. So you have to remember, if it's a frowny face, even though I'm doing 1, 3, 5, I got to go down with it. But look at number 6. So, opposite B over 2A. What does that give us?
-1.
I can't write. Yes, so X is -1. What is our vertex? -1, -3. Are we doing a happy face or a frowny face? Do you want to do the chart or do you want to do 1, 3, 5?
Yeah, we do one. No, we can't do one.
There's a step, one more step. But yes, you can.
How do you find the vertex again? I forgot.
Opposite B over 2A.
Right.
So we had -4 over 2 times 2. So that gave us -1.
Okay, and then how do you find the -3?
You took the -1, plugged it in to your equation. All right, vertex, -1, -3. And you've already said it's a happy face. Our method is called what?
1, 3, 5.
1, 3, 5. And that works when the lead coefficient is 1. What do you think you do if the lead coefficient's 2?
2, 4, 6.
Multiply it by
Almost. Wait, what?
multiply it by 2.
Multiply it by 2. So instead of 1, we're going to multiply by 2. Instead of 1, it's going to be over 1 up 2. Instead of 3,
Over 1 up 4.
no, multiply by 2.
2.
Over 1 up 6. Instead of 5, multiply it by 2. Over 1 up 10. If it were a coefficient, lead coefficient of 3, you're multiplying 1, 3, 5 by 3. So we would have 3, 9, 15 movements.
We don't have enough room on the thing for 10.
Most of the time, you're only going to have to do the first 2. That's why we couldn't even do it on the one that I showed you. They don't give you a big enough. But we can go over 1 up 2. Over 1, 1, 2, 3, 4, 5, 6. And then I go here. And then I go here. And then we graph. Ooh, vertex form.
2 and x minus 2 squared minus 1.
No.
Wait, what?
2,
Plus 1.
x plus 1, opposite h. H is -1, so you have to do the opposite of that. Squared, and then how do I end it?
But then minus 1.
Minus 3.
Oh, well.
The k, don't forget the k,
Yeah.
which is the y. What's the range?
-3, infinity.
Negative, all right, and we put a bracket, -3, comma. I see, I did that little curly Q, I can't help it. Positive infinity, because it's going up. If it were a negative coefficient, it's a frowny face, we would be going down. Remember, your vertex is your ceiling or your floor. So you use the Y to create your range, because range goes with Y. Ooh, this is a tough one. Who am I going to call on? Gabe, what's the question?
Good question. What's the question for?
What is the question? What are we missing?
The domain. What's the domain?
What is the domain, Gabe?
It's obviously 1.
It's all real numbers.
Oh, Olivia, all real numbers.
I was close.
And Trilby, every single quadratic equation when you're graphing and you're asked for domain, for every problem, it's all real numbers. All right. Are you comfortable with what we've done? I've thrown a lot at you today. That method, I think, will help you. The 1, 3, 5, don't forget if the lead coefficient is different than 1, you need to multiply it by the lead. Remember, frowny face, you count down. Happy face, you count up. So your homework is, you already have the homework sheet. That we did the back only. Now you do the front and the back. On the back, you're going to put the vertex form, because you've done everything else. And on the front, you're going to do everything, including the vertex form.
The vertex form is an option.
It's not an option now.
Wait, we need to do the vertex form on the front too.
And you have the homework sheet that you had last night. And you're going to work all of this, every question. Then you're going to flip it over, and you're going to put the vertex. Let me stop the recording just a second.
It's almost Friday.